There are some special unit vectors that we like to talk about, and we can write any of our other vectors in terms of them. I is the unit vector that moves one unit straight to the right. It's a horizontal vector that points to the right and is 1 unit long. My vector j is 1 unit straight up. Okay, not moving left to right, just a vertical line or arrow, I guess you could say, 1 unit long, pointed straight up in the air. When we're looking at vectors, instead of writing them in component form, some authors, or sometimes we like to write them as linear combinations of our unit vectors. Meaning if I take my unit vector 1 unit straight to the right, if instead of moving 1 unit straight to the right, I want to move 3 units straight to the left, then I need to take it times 3 to make it 3 units long, and a -1 to make it go to the left instead. Okay. Same thing with my -4. If I want to go straight down 4 units, I take my vector pointed straight up. I have to take it times a negative sign to flip it down, and take it times 4 to change the length. So maybe I have the vector w, and it looks like 2, -1. Instead of writing it in pointy bracket notation or component form, I could say I have 2 units straight to the right, -1 unit straight down. A linear combination of those 2 unit vectors. Sometimes this is just personal preference. If your author asks you to write it in terms of the unit vectors, you keep these same 2 numbers here, and you put an I with the x component and a j with the y component. So maybe I have the vector w that looks like 2i minus j, meaning I've gone straight to the right a certain amount, and I've gone straight down a certain amount. And I want to break that into components. Yeah, never mind. It is already broken into components. I'm mixing 2 ideas together. Maybe I want to find the angle there that it makes with horizontal. We're going to treat this like we would any other right triangle. Let's say the tangent of that angle theta that we make is the opposite side over the adjacent side. And then from there I can find my angle theta by using my arctan. Now I have to be careful because when I hit the arctan button on my calculator, it spits out only certain values in 2 quadrants. But I know if I'm going to the right 2 and down 1 unit, I need to give a 4th quadrant answer there. Okay. If I'm, yeah, so I'll type this into my calculator, and I'll see what comes out of there. I didn't bring my calculator, so I don't know what that's going to look like. Just in general, if you have a vector, okay, vector, I've used u and v and w, I'll just go back to u. Okay, not any of the u's that we've used so far. A lot of times it's nicer for us to break down these vectors into their components. Okay. So oftentimes I know, I mean, if I knew the direction, if I knew that this was 3 and this was 4, then I would be done. But if I want to measure my angle from horizontal, maybe I'm told the magnitude of my vector. Maybe I'm told that I throw the baseball at a certain velocity. Maybe I'm told something about the total force that's exerted here. But maybe maybe I know that that total amount there is 3. Okay, the magnitude of u. Maybe I'm told also that the angle Maybe I'm given something nice like 30 degrees. If I want to break this, I'm going to call it vector u1 and u2. I can write this resultant vector u as the sum of u1 and u2. I have a horizontal vector plus a vertical vector that gives me my resultant that goes off in this direction. If I know the angle that I'm dealing with, okay, I know the hypotenuse, and I want to find the adjacent side of that triangle, then I know that has to do with the cosine. I know the cosine of 30 degrees is u1, magnitude of u1, okay, over the hypotenuse. So that tells me the magnitude of u1 is 3 times cosine 30 degrees, which is 3 times the square root of 3 over 2, and that doesn't simplify. Okay. Similarly, if I want to know how long that vertical side is, I can use the sine function. And 3 times 1/2 is 3/2. If I want to write u in its components, maybe we'll write them as i's and j's. Okay. This u1 that I'm creating is just a horizontal vector. There's 0 steps up and 0 steps down. Okay, and this u2 is in reverse of that. I can write it as the magnitude of u times cosine theta, I'm just going to be generic there, times I, plus the magnitude of u times sine theta in the j direction. Okay, so we said 3 cosine 30 degrees, or 3 square root of 3 over 2 I plus 3/2 j is going to be our u. When we're trying to break it down and find its components, its x movement is y movement, and maybe all I know is its magnitude. Maybe I know its angle there. I can break it into component form by using the sine and the cosine. If I know the hypotenuse and the angle, and I need either the opposite or the adjacent side, I can use the sines and cosines to do that. Again, if we know the sides, if we know the x and y components, we can find the angle in between by saying the tangent of that angle is y over x. We're just back to those right triangles that we were using before. I'm going to make one more video that has some examples in it that are a little bit more specific, some of the word problem things. And then we're going to call it a night because my mouth's not working the right way.